What's up everyone, welcome to part 3 of our CNN model with Keras, and in this one we're going to look at how to get the embedding visualization working. So what you see here is the T-Sne visualization, and you can see here that we've got all of our images properly shown, and we can also show the labels for them so they're properly labeled. And yeah, so in this video we're going to walk through how to do this, how to create the Sprite file, how to create the metadata file, and how to save all your data in a way that it can all be read and interpreted by the projection in Tensorboard. So let's get started. Let's begin by talking about what an embedding is and also what projections are. So an embedding is a way of mapping our objects, which can be images or words, things like that, into vectors in a high dimensional space. So for our fashion MNIST dataset, each image is going to be a vector in that high dimensional space. So that's what an embedding is. It's taking our images and turning them into vectors in some high dimensional space. Now, what's a projection? Well, a projection is a way of taking those vectors in that high dimensional space and then projecting them down into a lower dimensional space like 2D or 3D, so that way they can be visualized. So that's what Tensorboard projection does. And the two types are Pca and T-Sne. So Pca is principal component analysis, and what it's trying to do is split the vectors into 10 principal components and then displaying them in 3D. And we'll see what this looks like later. And then T-Sne, which is T-distributed stochastic neighbor embedding. What this is trying to do is preserve the local structure of vectors. So for example, vectors that are close together in the high dimensional space, they're going to also be close together when projected down into three-dimensional space. So it tries to preserve that local structure, but there's no guarantee for the global structure. So for example, vectors that are far away in that high dimensional space, there's no guarantee what their relationship will be when projected down. So we'll see what this looks like later in Tensorboard. And just for reference, I got a lot of this information from the TensorFlow website, so feel free to follow this link and read more about it here. Cool, so let's continue on to give an outline of how the code's going to look like. So just to point out, the site that I found that gave a lot of good instructions for how to set up the embeddings and the projection in Tensorboard is this site here. So feel free to check out this link and see the code that they posted. So a lot of it that I'm showing here is based on this code. So the basic workflow for our code is going to be to read the fashion MNIST data, and then again we're going to create our X, which is images, and our Y, labels. So that's going to be our batch. So nothing new there. Then we're going to create what's called a summary writer, and then we're going to create an embedding tensor from X. So we'll see how to do that later. Then we're going to configure our projector. Then we're going to run a TensorFlow session and create a model checkpoint. Finally, we're going to create the Sprite image, and then we're going to create the metadata file or label file. Once we've got all that stuff generated, then we can call Tensorboard and view our embeddings. Now let's begin by coding this up. So I'm going to copy and paste a lot of this to save time, but let's start with our imports. So we're going to need OS, NumPy, Pandas, Matplotlib. We're also going to import TensorFlow STF from tensorflow.contrib.tensorboard.plugins. We're going to import projector. And then from TensorFlow examples.tutorials.mnis, we're going to import input data. Cool, so we'll run that. Next thing we're going to do is, like before, we're just going to import our data using pandas and then convert it to a NumPy array. So I'm going to create my test data, and we're just going to use pd.readcsv, read our fashion MNIST data CSV file, and then I'm also converting it to a NumPy array and changing the D type to float32 all in one line. Cool. And then the next thing I'm going to do is create something called Embed Count. And what this is going to be is the number of images in the embedding. So we're going to use 1600, and I chose this because it's a nice square number. Cool. And then we're going to split our data up into the X test and Y test. So X test is just going to be the test data. And then we're going to take this many, which is 1600 rows. And then we're going to take the pixel data and also divide by 255. So all the pixels go from 0 to 1. And then we're going to get our label data as Y test. So nothing new here. Then I'm going to create a variable called logdir. And this is just going to be the directory where we're going to log all of our data. So the checkpoints, the sprite file, the metadata, things like that. Cool. So I'll go ahead and run that. Next thing we're going to do is create the summary writer, the embedding tensor, and set up all the embedding stuff. So the summary writer is going to be this here. So summary writer is going to be tf.summary.filewriter, and we're going to write to our logdir. Next, we're going to create something called our embedding _var, and what that's going to be is tf.variable, and the variable is going to be xtest, and the name we're just going to call it fmnist_embedding. Cool, so that's our embedding variable. Now we're going to set up our config and our embedding tensor. So the first thing we do, I'm going to copy this stuff here, but we're going to create something called config, and that's going to be from projector and .projector config. So remember we imported projector up here in this big long import right here. So that's going to be our config, and then we're going to use that to do config.embeddings.add, and then this is going to be our what's called embedding object. And then finally, we're going to name this thing. Our embedding.tensor name is just going to be the name of this, which was fmnist embedding. Cool. So moving on, we're just going to set some paths. So we're going to set the embedding metadata path and the embedding sprite path. Even though we haven't created these things yet, we can still specify the path. So what we'll do is I'm just going to copy this stuff here. So the embedding.metadata path is going to be os.path.join, and then we're going to join logdir with a file that we're going to call metadata.tsv. So this is what's going to be our label data. So we're just setting the path, and then the embedding.sprite.image path is just going to be os.path.join. We're going to join logdir, and we're going to call our sprite image just sprite png. Cool. And finally, we also are going to specify the size of a single image in the sprite. So the embedding.sprite.single image dimension.extend is going to be 28 by 28. So that's the single image size, 28 by 28. Nothing new here. And then, finally for this cell, we are going to configure our projector. So it's going to be projector.visualize embeddings, and then we're going to pass the summary writer and config. So this is just information for Tensorboard to know that we want to visualize the embedding. Cool, so we'll go ahead, run that cell. Now we're going to do our TensorFlow session. So the way this works is we'll just do with tf.session as sesh. We're going to do sesh.run, and it's going to be tf.global, and it's going to be global variables initializer. And then we'll create what's called a saver, and that's going to be equal to tf.train.saver. Finally, we're going to call saver.save sesh, and then we're going to do os.path.join, and we're going to join logdir with our model.checkpoint. Cool, so we'll go ahead and run that, and I screwed something up. Oh, so hang on a second, I still have Tensorboard running, so I'll just pause for a second. Okay, I've paused my Tensorboard session and was able to run this one now. So continuing on. Next thing we're going to do is now build our Sprite file or our Sprite image. So what we'll do first is I'm just going to create a few variables. So the first one is just rows and columns, which are going to be 28 and 28. And next what I'm going to do is create a list, and the list is just the names of each of the item types. So if you remember, the labels are just numbers 0 to 9, but what they actually represent are, either pants, shirts, sneakers, things like that. So this is just so we can get nicer labels in Tensorboard, which actually say what it is instead of 0, 1, things like that. Cool. So now what I'm going to do is define the dimension of the sprite. So what that's going to be is, because I chose a square number up here, 1600, the dimension of it is basically just going to be the square of that number. So I'm just taking the shape of x test, taking the square root of it and make sure it's an integer. So it's basically just going to be 40, which is the square root of 1600. Now I'm going to create a NumPy array that's going to be the template for the actual sprite image. So what that will be, I'm going to call it sprite image, and I'm going to use np.ones, and the dimension of it is going to be the columns times the dimension of our sprite times rows times the dimension of our sprite. Cool. So continuing on, now I'm just going to create a list called label, and this is just going to hold our labels. So you'll see here we're going to do a double for loop. So we're going to do for I in range sprite dim, then also for j in range sprite dim, and then we're going to define something called the index. So index is just going to be I times j. Then what we're going to do is labels dot append, and then what we're going to append is the actual label, which is this here, and then we're going to pass into it an integer, and the integer is going to be y test, and it's going to be y test of the index. So this is going to say, okay, what is the label at this index, and then label, this label here is going to convert it to a name. So actually the list needs to be labels, and this is going to be label. So yeah, try not to screw that up. I did it a few times, but that's set up correctly. So moving on, now what we're going to do is for our sprite image, I'm going to define how we're going to assign each sprite in the image. So our sprite image, and we're going to index it by from I times the columns to I plus 1 times the columns, and then j times the rows to j plus 1 times the rows. So it's going to be in chunks of 28 each loop. And then what that's going to be equal to is going to be, let's just copy this here. It's going to be x test and then x test at the index. And then we're going to reshape it by 28 by 28. And then finally, what we're going to do is multiply it by -1 and then add 1 to it. What this is doing is just inverting it from black and white to white and black. So this gives us a white background instead of a black background. Cool, and that will create our sprite image. So now let's create the metadata file. So the way we'll create our metadata file is it's going to be one column, which is going to be an index. So just a number, 0, 1, 2, things like that. And then it's going to be the name. So it'll be like sandal, shirt, pants, stuff like that. So the way it works is we're going to do with open, and then the path to our file is going to be metadata path. And then we're going to open this file with W. We're going to call it meta. Cool. So the first thing we're going to do is meta.write, and what we're going to write is index, then we're going to do a tab, then we're going to do label, and then we're going to do a new line. So because it's a tab separated file, we have to have tabs between everything. So we're just getting some, or adding some names to the column. So the first one's index, second one's label. All right, then we're going to do a loop. So for index and label in enumerate, and we're going to enumerate the labels. Then we're going to do meta dot write, and then we're going to write the index, add a tab, then we're going to write the label and add a new line. So then we format it, and then like I said, we're going to pass index and label. So finally, just so we can see what the sprite image looks like and also save it, we'll do plt.imsave, and then because I don't want to screw this up, I'm just going to copy the rest of it here. So the path is going to be embedding.sprite.image path. We're going to save the sprite image, which we generated in the loop, and then we're going to save it as a gray image. Finally, we'll do plt.imshow, and we're going to show the sprite image, and we'll show it as cmap equals gray, and then we'll call plt.show so we can see it. So this is what it looks like here. It's kind of hard to see, but I'll pull it up just so you can see it a little better. So you can see it's just a bunch of the actual sprite files. So we've got shoes, shirts, jackets, all that stuff, just in one big file. And also, so you can see what the metadata looks like, it's just like the column or the index, and then what it is. So t-shirt, trouser, pullover, you know, all that stuff. Cool, so that's what the sprite image and the TSV image looks like, or the metadata file looks like. And that's actually it. That's all we need to do. So now we can call Tensorboard, specify the logdir where we saved everything, and we should see the embedding. So let's go ahead and do that now. So now in order to start Tensorboard, we're just going to pull up a window called Tensorboard, then -- logdir, and set it equal to our logdir path. So now I'll run this, and you can see the Tensorboard server begins. And now what I'll do is just pull up a new browser and go to localhost on port 6006. And now when I run this, it should read the sprite file, the PSA, or the metadata file, and show all the embeddings in the graph. So I'm just going to zoom out so this stuff isn't so big on the side. And this is now showing Pca. So you can see all of those images projected into the space. You can go through the different components and see what they look like for the 3 axis. So each axis, X, Y, Z, you can specify a different component and then just look what the space looks like, pan around and zoom and all that stuff. I prefer setting the color to labels, so that way it's a little easier to see what it is. And you can also click this button here and it'll actually say what the label is. So trouser, pullover, all that stuff. So that's what Pca looks like. I'm not an expert in it, so what I'd recommend is reading more up on it in the TensorFlow website. They've got links to better documents that explain all the math behind it. But yeah, so let's move on to TSNE. So then you can just click this button here. It might be kind of small, but you just click this, and then what it's going to do is show the progression of that projection into lower dimensional space. So it should, these things should group into like items. I think maybe because the checkpoint that we had was not a good model, so it's probably not going to cluster into very like well-defined groups of shirt and shoes and all that kind of things. But with that being said, you can play with these hyperparameters like perplexity and learning rate, stop it and then rerun it just to see what other ways it converges to, things like that. Like I said, I'm not an expert on the math and all the theory behind this, but you can read more about it on the TensorFlow website. There's lots of links to good articles which will teach you about it. But the goal of this video was just to show you how you can get this thing going with a data set like Fashion MNIST. So I hope you guys like this video. It took a while to get this stuff working correctly, but I really wanted to do a better, more comprehensive version on it because the previous videos kind of got a lot of dislikes. So hopefully you guys like this one. If you've got any questions, you can leave them below or use the Facebook group. I'll post all the code to my GitHub so you can download it and play with it and do whatever you like with it. So yeah, in the next one, we'll explore more about how to make a better model than the basic CNN model we've got and just build on top of that model. So stay tuned for the next one, and I'll talk to you guys later. See ya.